In this video, we're going to look at how to come up with sinusoidal models, how to write the equations to fit a situation. So this situation says a group of students are tracking Mr. Bueller riding a Ferris wheel. They know that he reaches the maximum height of 11 meters at 10 seconds and then reaches a minimum height of 1 meter at 55 seconds. At the start of the ride, he was 10 meters off the ground. We are to come up with an equation that models the height of Mr. Bueller above the ground. So we know that someone's height around a Ferris wheel, we know that that's going to be periodic because it's going to repeat, repeat, repeat. We also know, we've seen Ferris wheels before, we know it's going to make a sine or cos curve. So let's take a look at what the equation of a sinusoidal model looks like. So a sinusoidal model could be sine here or it could be cos here. So we know that A stands for the amplitude. K tells us information about the period. D is our horizontal shift. And C is our vertical shift, or our axis of the curve, the middle of the graph. So now just from these words here, we have to be able to find the amplitude, the period, our shifts, and our equation of the axis of the curve. So how do we do that? Well, one way is to make a t-table out of the information that we're given. So what are we measuring here? So let's just make a quick t-table here. In this question, we're given time and height of Mr. Bueller. So those are the two things that we're measuring here. We're measuring time, and it seems to be in seconds, and we're measuring height, which is in meters. So what are we given? We are given that we know that he reaches a max height of 11 meters at 10 seconds, and then a minimum height of 1 meter at 55 seconds. And at the start of the ride, he was 10 meters off the ground. So let's put those points in there. So we know that at a time of 0, he was 10 meters off the ground. I don't know why I put seconds here. This should be meters. So I'm just going to erase this. There we go. Now it says meters. Okay, so this part is we've included. Let's just highlight it so we know it's done. At the start of the ride, he was 10 meters off the ground. So at time 0, he was 10 meters off the ground. That makes sense because there's probably a little platform that the Ferris wheel is on, and it's 10 meters off the ground. So now we know that he reaches a maximum height of 11 meters at 10 seconds. So let's write that in. At 10 seconds, he reached a maximum of 11 meters. So I'm just going to make a little note that that is our max. And then he reaches a minimum of 1 meter at 55 seconds. A minimum of 1 meter at 55 seconds. 55 seconds, 1 meter. So remember how I originally said this must be the start of the ride? They can't be true. So this must be just when the information was starting to be recorded. So at time 0, that's when right before the information was starting to be recorded, Bueller is at a height of 10. So he's going to go up to a height of 11 and then down to a height of 1. And that's all the information we need to be able to fill out the rest, because we know a Ferris wheel, the heights are just going to keep repeating over and over and over again. So we need to come up with the pattern of when he's going to reach his maximum again. So that's his max, this is his min. So just imagine he's at 11 meters as max, and he goes down to 1. Then he's going to go back up to 11, back down to 1, and so on and so on, so on. So the question is, how long did it take him to go from the max down to the min? Well, what's the difference between 10 seconds and 55 seconds? Let's just zoom in here. The difference is going to be 45 seconds. So every 45 seconds, Bueller is going to go from the max to the min. So we start at the max, down to the min. How long is it going to take him to come back up to the max? It's going to be another 45 seconds. So we're going to put plus 45 seconds. And so what second mark are we going to be at now? We're going to be at 100 seconds. 55 plus 45 is 100. And where will he be? He started at the max, he went to the min, he's going to be back up at the max. So here we go, we're back up at the max again. And so we started at the max, min, max. How long is it going to take him to go back down to the min? It's going to be another 45 seconds. So we're just going to keep on adding 45 seconds until we feel like we understand what's going on here. So now we're at 145 seconds. We could change this to minutes if we want, but I think it makes sense to keep it seconds. What's the height going to be? So we're at the max, then we're at the min, then we're at the max, now we're back at the min, 1. So back at the min. So once you feel like you understand what the pattern is, now we can start figuring out what these letters are, A, K, D, and C. So if we were to sketch this guy, it's going to look like this. Sometimes a sketch will help us. So when you're doing a sketch, you're literally going to spend no more than 10 seconds on this sketch, okay? So we're not going to do a scale, nothing. We're just going to put the information that we need. So on the x-axis, we have time, and on the y-axis, we have height. And then we've got just 10 seconds, 55 seconds, 100 seconds, 145. And the only heights that are important are 1, 10, and 11. So that's what I'm going to sketch on here. So we've got 1, we've got 10, we've got 11. So really quickly sketching this thing, we've got 0, 10 is 1 point here. And then we've got after 10 seconds they're at a maximum, and then after 1 second minimum, after 55 seconds minimum, after 100 seconds back up to the maximum, after 145 seconds back at the minimum. And let's just connect this here. So there we go. There's our sine and our cos curve. So just going to continue. So we have to come up with an equation for this. So we're just going to find each letter one by one. How can we find the amplitude? So let's start with A. How can we find this amplitude? What do we know about the amplitude? We know that the amplitude is just going to be the max minus the min divided by 2. Do we know what the max is? Yep, it's 11. Do we know what the min is? Yes, it's 1 divided by 2. So it's going to be 10 divided by 2, which is 5. So we have our A value. Let's do another one. How about K? Let's do our K value here. So our K value. So we know that the period is going to equal 360 divided by K. So I can rearrange this to say that K is going to equal 360 divided by the period. Okay, and all I did here is just rearrange this guy so that K is isolated instead of the period. So these two are equivalent. K equals 360 divided by period is the same thing as saying period is equal to 360 divided by K. So we don't know the K value, but can we find the period? The period is the length of one cycle. So if we use our little sketch, it's really easy to tell how long does one pattern take. Well, I can look at it from here to here, from here to here. How long is that? How long does it take to get from 10 seconds to 100 seconds? The period is 90, isn't it? How long is it from 10 seconds to 100 seconds? Well, 100 minus 10 is 90. Does this 90 make sense from our chart? Well, to get up from the max to the min, it's 45 seconds. And to get back to the max is another 45 seconds. So from max to max, it's going to be 45 times 2, which is 90 seconds. So however you come up with the period, whether it's from the chart or it's from the sketch, it doesn't matter, as long as you realize that the period is 90 seconds. So we're going to do 360 divided by 90, and we know that that is 4. K is equal to 4. Let's keep going. So we've got our amplitude, we have our K value. Let's leave the horizontal shift just for 1 second, and let's use our C value. Let's figure out our C value. So we know C is just the equation of the axis of the curve. How do we come up with C? We know how to do that. We know that our equation of the axis of the curve, so we'll call it y equals, is just max plus min divided by 2. Max plus min divided by 2. It's just our average. So we know the max is 11 plus the min is 1 divided by 2. So we know this is going to happen at y equals 6. 11 plus 1 is 12 divided by 2. So we know that our C value, we know that our C value is equal to 6. So we have our A, we have our K, we have our C. The last step is our horizontal shift, okay? Our horizontal shift. To figure out our horizontal shift, I'm just going to zoom in here. Okay, so what we need to do to find our horizontal shift is the easiest way is just to do it visually. We need to look for sine or cos in this graph here. We need to look for sine or cos in this graph here. So what does cos generally look like? We know cos looks like the bowl, like that, right? Starts at its max, ends at the max. And then we know sine starts at the middle, comes up, comes back down again. So sine starts at the middle and cos starts at the maximum up here. Okay, so what can we find here? Which one is easier to see? Are you thinking that this is sine? Because it's not. Because this doesn't start in the middle. It would have had to start at 6 for it to be sine, okay? So we can't see a sine curve here unless you want to talk about it starting here. We could just figure out what that x value is, fine. But do you notice that there's a really obvious cos curve here? Look, watch me highlight here. Starts here, comes back up. Do you see that little cos curve here? There's the bowl, right? Start at its max, min, back again. That is our cos curve. So normally cos starts right at the y-axis, right? Right at the y-axis. It's been shifted. How much has it been shifted to the right? It normally exists right here, but it's been shifted. It's been shifted 10 units right. So that is our horizontal shift. If we use the cos curve, we can use it, but we're just going to say it's been shifted 10 units right. It's so hard to do that without a sketch. So I really, really recommend doing a sketch because then it's very easy to tell. So let's take a look at our D value. So if we use cos, then we know that it's been shifted left, sorry, not left, right 10 units, right 10 units. So that would mean D is equal to 10. So it only asks us for one equation, so there's no need to come up with another one. But let's say that you wanted to use sine. So we know sine starts at the middle, comes up, comes down again. Where do you see sine? This is an upside down sign, a reflected sign. You could use that. But let's see if you can find where it goes up to its max, down to its middle, and back to the middle again. How about here? Up, down, back again, right? Let me just highlight it. So taking a look, let's do green here. Here's where sine looks like. Up, down, back again. Here is sine. See that? Okay, right here. There is sine. The question is, we don't know what this number is. Can we figure it out? Can we figure it out? Well, we know that the curve reaches its minimum at 55 seconds and its maximum at 100 seconds. So what's in the middle? What's in the middle of 55 and 100? All we have to do is add these together and divide by 2. And we get 77.5. So it's not nice, but this number here is 77.5. So if you wanted to use sine, you want to say, okay, really, I'm obsessed with sine. I don't want to use cos. I want to use the sine curve. Then you could say that sine has just been shifted to the right 77.5 units. Now, if we have a choice, why are we going to use that, right? It's so much easier just to use cos. So that's what we're going to use. So now we're ready to put it all together. So the question was originally asking us to come up with an equation. So to find an equation, we need all of these letters. And to find each of these letters, we just made a table. Then we made a quick sketch and we're able to find everything that we need. So let's put it all together now. So we've got y equals, instead of we'll replace y and x at the end, but let's replace a, k, d, and c first. Our amplitude a is 5, so we're going to write 5. And then what curve did we choose to use? We chose to use, not sine, we chose to use cos. So I'm going to put cos here. Bracket, instead of k, we found 4. So we're going to place it. Then we've got x. Now we want to shift this thing to the right 10 units. So should this be plus 10 or minus 10? It's got to be minus 10. We know everything in x land is opposite, right? So this means shifted to the right 10 units. And then how much was it shifted up or down? Or what's the equation of the axis of the curve? And we found it was 6. It's going to be plus 6. The last step for us to do is to just replace our x and y with the variables that we know. So let's just erase them quickly. So let's replace x and y with the letters that we know. What is our y? It's our height. So I'm going to replace h with h, or h at t, let's just say. And we know time is, or x is just time, so we can put t. If you really don't want to put h at t, you can put h, same thing. So last, let's just use this lovely equation that we came up with. So we did it. Lots of work, but we did it. And let's just answer this last question. It says, determine Mr. Bueller's height at 70 seconds. So we're looking for height. So h equals, we don't know, when t is equal to 70. So let's do it. So we're going to plug it into our equation. So we have h at 10 is equal to 5 cos bracket 4. Instead of t, I'm going to put 70. 70 minus 10, end bracket, plus 6. And let's throw it all in the calculator. I'll do one quick calculation first. I'll just put cos of 4 times 60. Sorry, I just had a brain fart there. Plus 6. And let's throw in the calculator. Before we do, I predict it has to be somewhere between 11 and 1, right? That's the maximum 11. That's the minimum 1. So our answer better be between 11 and 1. Let's check it in the calculator. And I got 3.5, which is between 11 and 1, so far so good. So what's our conclusion? Therefore, after 70 seconds, Mr. Bueller is at a height of 3.5 meters on the Ferris wheel.